Hi, so we will solve this Leetcode problem, adjacent increasing subarray deduction 2. So let's see what's the problem statement. So here it is saying basically that we are given an array nums. What our task is to find the maximum value of k. Now what is this k? So basically this k, as it is given here, uh, we have to create we have to find two adjacent subarrays, each of which will be of size k. Okay, and what's the other property? They both should be strictly increasing. Okay, uh, adjacent, and they should be strictly increasing. Okay, and both of the subarrays will be have of size k. Okay, so and now we have to find the maximum value of this k. So let's take some simple example. Let's say we have 3 4 5, and then we have 0 1 2. So what it is saying that we have to find the maximum possible value of k. So just directly I will just show you like what it will be to get the clear picture. So here you can see it is like 3 4 5 0 1 2. So what, this is an increasing, this is an increasing. Okay, and what is the size? They both should be of size k. So k you can say is, k here is 3. Okay, so now our task is to find what could be the maximum possible value of this k. Okay, so let's, so what do you think, like what ideas or intuition is coming, how it could be solved? So basically what intuition, the first time I got, it was like there could be two possible ways ideally, right? what what those are? One could be like the final answer where we are going to get the maximum. It could be like a single increasing subarray, the longest increasing subarray. Okay, yeah, or otherwise there could be two subarrays of size k. Okay, so this intuition is, I think, clear that there are two possible ways only. Okay, so now let's like take an example of both. So in this example you can see like this is a continuous increasing. Now there are two possible ways. One is this, uh, one is this, where k will be equal to 2. But here if you see, this itself is an increasing subarray of total size is 6. So what if I divide this single increasing subarray into two subarrays? Then our k will come 3. Why k will become 3? I can divide it into these, right? So there are two increasing subsequence, but here the answer will be k equal to 3, not 2. So this is like the question, like we have to find the increasing two subarrays basically. So there are so as I said, there could be two possible ways. Either a single longest increasing subsequence we can find and divide it by 2. This will give us the k, or the basic intuition is like we will find two different subarrays which will be adjacent. We will then we for all these possible scenarios we will see like what could be a k, and we will then return the maximum k. Okay, intuition from example. So, so after seeing this example, uh, what we are getting an intuition is like keep the track of increasing sequence. So whatever increasing sequences we are getting, here we are getting 1 2 3 4 5 6, this is one increasing subsequence. So at every moment we have to keep track of these increasing, like here we are getting 1 2 3 0 1 2. So then only we could find these two cases, and then we will merge the result basically, right? Okay. Let's move towards our solution. So how to approach basically, right? For the case 1 we will solve, and then for case 2, and then we will merge it, simple. Okay, I have taken one example. So it is a continuous increasing subsequence. So what we have to do is like traverse the array. We will traverse, these are index 0 1 2, and this is our nums of I 1 2 0 5 6. We will maintain a counter. This C is like it will count the number of elements in our this sequence, right? So when we are on the first element, our count will be 1. We will start from the first. Now what it will check simply whether this element is bigger than the previous one or not. So our counter will update to 2. Similarly 3 4 5 6, you are getting the idea, right? We are simply finding the size of the increasing subsequence. Okay, so now my question is like, if this was the given array and we are talking about the case 1 where a single increasing subsequence is the answer, this. So tell me what will be the k here. So we will say, since the size is 6, total size is 6, we can simply divide this bigger subarray into two parts of equal size, right? It will become k. Yeah, that's right, k will become 3. Yeah. Okay, now we will solve case 2. So case 2 is like case where we have to find two subarrays. So it simply means whenever there is a break, you see here is a break, whenever there is a break, it means a new subarray is going to start basically. So now we have to keep track of the previous also and the current one also, so that when this completes we can compare this one with the previous one. Okay, and we will keep tracking like what is the maximum possible value of k possible. Let's see an example. So we need to keep track of previous and the current count. Why? So I think this is, yes, you got it. Then only we can find like what will be k. Whenever there is a break, you got it, like, right? A new sequence will start and we need to compare this one with the previous one. This is like answer to why. Okay, so let's see an example like 4 5 6. This was an increasing, and here also a 1 2 3 4. This is another one increasing subarray. So here also we will maintain our counter. Let's say this part was completed. Now our I reached this breakpoint. So when we reach the breakpoint, now it means a new subarray is going to start. So we have to start our counter from 1. So that now as we traverse this, so it will become 2 3 4, as it is going to satisfy like 2 is greater than 1, 3 is greater than 2, 4 is greater than 3. So we are maintaining the our counter. So now can you like tell what will be the possible value of k? Let's say our I was here. Okay, our I was here. So for this new, and we know that this, we never know like whether after this we have elements or not. At the current point when our I is here, what you will do to find, like let's say this was our answer. Okay, so how we will find? we will simply say, okay, the size of this is 1. How many elements we can take from the previous subarray which are satisfying our condition. So previous increasing, we know it was like this p, the size of p, we know, right? Because we will maintain like the like previous one, previous increasing subarray, what was the size, we will maintain this. So now when we are at I, you will say, okay, the previous one was p and the current subarray size has only 1. So what could be the possible k? Because we know that both have to be of same size, so we will take minimum of c and p here, right? Why minimum? Because uh, because if one of the because we need to keep the size same, right? We cannot have the maximum, the p value, or anything bigger than the current c, because we have to keep both the subarray of same size, right? So whenever our eye is traversing, as we are moving forward at every point, at any random point, we will simply see the current c and the previous p, what was its value, and we will take the minimum, right? Only minimum is possible. Okay, so here you see, if when c was 1, we said 1, it become 2, so 2, because p here, value of p is 3, so we have to take minimum. So when it become 3, both were equal, but when c became 4, right, then what will be k? You cannot say like I will take all these 4 and these 3. It is not possible, right? Why? Because 3 is not equal to 4, and uh, we need both of them to be equal. So now we have seen like both the cases, how to solve them individually. Now we like simply see the code and like how we can combine it, right? So here's a code, very simple code. So what we are doing here, so let's first see our case 1, like how case 1 is implemented here. So this is like, firstly we'll see the variable, and is like length of our array. PC means previous count, CC means current count, and K is like our answer which we have to return. Okay, so if you see, we are traversing from 1, not the 0, because 0th index is like at that place, as our we have initiated our variable as 1 1, so it is like it is by default, like it is like also our edge case. What if only 2 elements are there? So both of them will be like individual sub arrays itself, right? Let's say we have 1 2 only, so it means our k is like 1 1, right? So that's why this is like, we know this is going to be our sub array. If let's say this is 1 1, so let's see. Okay, so here we are simply checking our depth condition strictly increasing, and whenever it is true, we are simply increasing our current counter. Okay, so you see like when this, and at every place, what we are doing after every if, so what we are doing here, so for whenever this if is completed, and for now we are seeing only case 1, whenever this if is completed, what we are doing here is finding max of k and cc by 2, current count by 2. Why we are dividing it by 2? As we have seen, whenever there is a strictly increasing single subarray, we can divide it into 2 parts, k. So that's why our k can be this cc by 2. Okay, So now this by this logic we are handling our case 1. Okay. What about um, case 2 now? So how case 2 is being handled? So for that case 2 we are simply maintaining the previous count. How previous count is being maintained? Let's say take an example like 1 2 3 0 1. If this was our, and let's say we reach at this point. So when we reach this point, our CC at this point is 0 1 2. Here it was 2. Now when we went to this condition fail, we come inside our else. What? So now we are saying that previous count should become current count. Okay, because we need to track our previous subarray size, right? So that we can in future compare it with the current subarray. And now since we are here, we know a new subarray is going to start. We have initiate our current count to 1. And now how we are handling it here? As we see previously, that we have to take minimum of current count and the previous count, right? And overall we have to find the maximum. You have to return the maximum value of key. Now I think it is clear. And also one more thing, why we initiated k equal to 1, because this is the least possible answer. Let's say h case we have only 2 elements. What you will return? You will return k equal to 1, because because single elements could themselves behave like an increasing subarray, right, of size k equal to 1. So that's why we have initiated k equal to 1. CC, PC, I think these all are clear now. Okay, thank you.